the second parameter to be measured is input bias current and input offset current. So for this kind of circuit configuration is used, where both this again inverting configuration with 1 mega ohm resistor connected in feedback, with there is parallel switch connected to the resistor. Similarly to the non-inverting terminal, there is again 1 mega ohm resistor connected, and parallel to it there is one switch connected, and it is grounded. So, and output is at pin 6. Biasing is given as mentioned earlier, using the dual power supply, shorting these two and taking ground common, plus VCC minus VCC. Due to lack of components, I am going to explain it on paper itself. So this is the IC that we are going to mount, IC741, on the breadboard. So we are going to mount it as shown. We'll be mounting this IC on the breadboard like this. So there is a procedure to measure the input bias voltage. The procedure is that basically the formula for input bias voltage, input bias current is IB is equal to IB1 plus IB2 divided by 2. IB1 is nothing but the current through first branch, the first input, and IB2 is current through second input. These currents are not measured directly, but there is a procedure. The switches connected in parallel to each resistor are to be switched on and off, like close and open, and then the current calculations are to be taken. So first step is to close switch S1, that is over here, to close, that is short circuit, and open S2, that is open circuit S2. Then we will measure output voltage at that condition, which will be VO1, and to measure IB2 we will divide that VO1 with 1 mega ohm value, which will give us IB2. Now the second step is to calculate IB1. For that we have to close circuit S2 and open circuit S1 and measure the output voltage VO2 at that condition. So VO2 divided by 1 mega ohm will give you 1 IB1. And to calculate input bias current, we will add the values of these two. Simply add it mathematically, that is algebraically, and divided by 2, which would give you input bias current. And to calculate input offset current, we will take the modulus of IB1 minus IB2. That would give us input offset current. So this was theoretically. Practically, let us see how it is happens. So we have to make similar connections on breadboard as of this. So as we can see here, there is 1 mega ohm resistor connected between output, that is pin number 6, and inverting terminal, that is pin number 2. Therefore we have done similar connections here between pin number 6 and pin number 2. We have connected a 1 mega ohm resistor, and parallel to it is this S1, that is switch 1. Now for the non-inverting terminal, there is 1 mega ohm resistor connected and it's grounded. The second terminal of it is grounded. Similarly, parallel to it is S2, the switch 2. So here we have done same thing. It is, this will be on breadboard, all these things I am doing it here. So the positive terminal, that is pin number 3, that is S2, you can say, sorry, the pin number 3 is positive terminal. So the resistor is connected in series with it like this and grounded, and one switch is connected, S2 is connected in parallel. So by the 2 steps we can measure the input bias current and input offset current. So first step is close S1 and open S2 and measure output voltage. So output voltage will be available at, will get at pin 6. So again we have to connect the DMM between positive the pin 6 and ground, and we have to measure the output voltage. So first condition is close S1, that is you have to close this or short circuit this and open circuit S2. So close S1 or short circuit S1, open circuit S2, measure the output voltage, that will be VO1 for the first condition. Then for the second condition, okay, for the first condition, then to measure IB2, we have to divide the value of VO1, whatever the DMM reading shows, the output voltage, divide it with 1 mega ohm value. So it will give you IB2. Then to calculate IB1, we have to calculate VO2. For VO2, we have to condition close S2 and open S1. So here we have to close circuit or short circuit S2 and open circuit S1 and measure the output voltage on DMM. So that output voltage will be VO2 divided by 1 mega ohm value, it will give IB1. Now to calculate input bias current IB, we can simply divide the two values of IB1 and IB2, add the two IB1 and IB2 and divide it by 2. That would give us input bias current. And to measure input offset current, we have to just take the modulus of IB1 minus IB2. So the final current will be positive because it is modulus of subtraction of currents. So this is how we'll measure input offset current and input bias current.